Hey everyone, welcome back to another episode of Arduino build walkthrough. This time we're going to create our own functions and our own custom LED strip effects. Before we get into that, let's hear a word from our sponsor, Rainbow Keyboards, because we just love LEDs that much. Yep, let's get into it. So first thing we need to do is open up Arduino. Oh, and by the way, I'm at home and I'm using my personal computer, which is a Mac, and I am a nerd, so I changed the colors on Arduino, so that's why it looks a little bit different. Okay, so let me get that. Alright, so we're going to start off just like last time. We're always going to start with a comment detailing what we want to do. In this code, we're going to create a code that uses a custom function. We're going to create a custom function to run the lights. Okay. Step one, just like last time, we need to include the Adafruit library. Okay, so we need to throw down a hashtag include open caret. It's called Adafruit underscore neopixel.h. Okay. Step two, we are going to define our variables. In this case, we're going to be telling the Arduino where we plugged in the LED, as in which data pin we plugged it into, and also we need to tell it how many pixels are in that LED. So we're going to do the number of pixels and the pin location. So just like last time, we're going to be a little bit more sophisticated. We're going to do the hashtag define, because why not? We're moving up in the world. Alright, hashtag define number of LEDs. We'll just say N LEDs this time. So we're going to have 8 LEDs, and we are going to give the pin location LED pin as number 6. You know what? Let's get weird. Let's say number 5. We're doing number 5 this time. Doesn't really matter. As long as it's a pulse width modulation one, we will be okay. Alright. Is there anything else we need to do here at the beginning? I think oh yeah. Step 3, we need to start up or tell the Arduino that there is a LED strip in here, and we need to give it some information about it so it knows what is plugged into it. So what we're going to do, we're going to use the use a command from the library to store info about the LED strip, so the Arduino knows who it is talking to. Alright, so we're going to have to use a command from the Adafruit underscore neo pixel library should turn red. We're going to call this the strip, just like last time. We're going to tell it the number of LEDs that went in here. We need to tell it the LED pin. And we also need to tell it what type of strip we have. The type of strip is going to be the exact same one as last time, so it's neo._grb plus neo_khz 800. Alright, cool. So we got that all sorted out. We are good to go into the setup. Leave everything in the setup. I'm just going to click here, push down, make sure you leave the squiggles at the bottom and top. Okay, so click in the inside here, hit tab because we're not barbarians. We don't chew each other's gum don't chew our toenails, so don't be weird. Don't use spaces. We need to set this up, so we need to tell the strip to begin. Put a semicolon. And we are good for the setup. That's all we need to do. So now at this point we have a code that literally does nothing. Oh, let me put a comment in here. Alright. So step number 5 is going to be a little weird. We're going to skip the void loop because the void loop is the main section of code. That's where it executes. That's what it runs repeatedly. However, in this code, we are going to be creating a new function. So just like up here where we had this function called Adafruit NeoPixel, where we created a thing called a strip and gave it some information, that is a function. We're going to be making one of our own of those. So in this code, we're going to skip over this entirely, over the void loop. So we're going to go down below void loop. We're going to make our own void. That's right. We are venturing into our own void now. Okay, and let's call our function color wipe, and inside the color wipe we are going to need an unsigned integer of 32 bits. Okay, we're going to call that the color, and we also need to set the wait time. Okay, open a squiggly bracket, hit enter, and you'll see a new one pop up here. So what the heck did I just do there? Alright, let me explain. Let's call this step 5. So we're creating our own function. All functions are like, that's what a void is. A void is basically, in Arduino words, that is a function. So we're saying here we're creating a function, we're calling it color wipe, and to make this function work we need to give it two things. First, we need to give it a color in the form of a 32-bit number. That's what this unsigned integer 32 uint 32 underscore t, that means unsigned 32-bit number. We're just giving it a number basically, and that number is going to represent a color. And then we also have to tell it a wait time. If we don't tell it those two things, whatever we put inside of this function will not happen. Okay, so we are creating a function just like up here where we have strip. We had to tell it the LEDs, we had to tell it the LED pin, and then the types. These are what we call arguments. This one has 1, 2, 3 arguments. We're creating a function that has 1, 2 arguments. Okay, so when we go to call this function, when we go to use it, we'll have to give it 2 pieces of information. And that's basically all we are doing right now. Just a little bit of background. Why is a color a 32-bit number? Well, remember how when we set colors, we set the red, the green, and the blue. Okay. Well, each one of these numbers could be a total of 255. Oops. So 255. Oh, what am I, a barbarian? Okay. The number 255 is an 8-bit number. So we have 3 of them, RBG. 8 times 3 is 32. That's where the 32-bit number comes from. So this explains why it's a 32-bit number, because red, green, and blue are all 255, or can be up to 255. 255 is an 8-bit number, since we have 3 of them. 3 8-bit numbers, we need 32, because 3 times 8 is 32. That's where that comes from. All right, so inside of there, we're going to do a little bit of programming. We need to tell it what to actually do. So if we call this function and we put in the necessary information, what is it actually going to do? Well, we want it to color wipe. We want it to change a whole bunch of colors. All right, so how do we do that? Well, first we need to set up a for loop, just like we did for last time. We're going to make it for an imaginary variable called I that we're going to start off at 0. We're going to say as long as I is less than the number of LEDs, then we are going to do the thing inside. But every time it finishes executing the code inside of here, we are going to add 1 to I. Okay, so at the end of that, add a opening squiggle, hit enter, and it should put a closing squiggle underneath it for you. All right, next we need to tell the strip, the LED strip, to set pixel color, and we're going to set it, so this set pixel color, it turned blue because that's a command. That command requires 2 arguments. First, we need to tell it which pixel we want to set the color on. We're going to set it to the pixel I. So at the first, it's going to start at pixel 0, which is the first pixel, and every time it executes, it's going to keep going up the chain. That's why this is a color white, because it starts at the bottom and it goes boop, boop, doo, 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 doo. It goes the whole way up, right? So we're going to start at pixel I, and we wanted to change it into color. Notice this color right here, that is this color. So when we call this function and we put a color, we put those 255, 255, 255, we put those 3 numbers in, it's going to be that. Okay, so it'll know to put that in there for us. And then we're going to say, okay, now that we set that color, we need to tell the strip to show. So it's going to actually show that. And then we are going to delay whatever amount of time we designated when we called the function. So this wait is going to go in there. Okay, so now we have created a function. In this function, it's going to set LED pins, or it's going to go through each and every LED pixel, set the color of that pixel to whatever color we said. It's going to show that pixel, and then it's going to wait, and it's going to do the next one. Okay, so step 6, give ourselves a little space, hit indent, hit tab, because we're not barbarians. Call the function. All we have to do is we're going to say, hey, color wipe. I want to, we had to put in 2 arguments because we put 2 arguments here. We had to tell it the color and the wait time. So let's go to Google. Okay, so let's pick a color. What color you want to do? Yeah, let's do a green. Yeah, let's do a weird green. Alright. So I'm going to do these ones, 108, 245, and 49. 108, 245, and 49. Oh, wait, I forgot. There's a second thing we have to put in here. Wait, that doesn't make any sense. Oh, okay. We can't just do that. It's got to be strip dot color. Okay, so you'll see when you write strip dot color, that'll turn blue. I realized that I was making a mistake because I was writing 3 different 8-bit numbers instead of compiling them into one number. This function here will take those 3 numbers, put it together into one thing. Okay, so I'm going to say we want the color to be, what is it, 108, 245, and 49. Close that. Hit a new comma, so the comma separates the arguments. The second argument we had to have is the wait, And the wait time, let's do 50. All right. And then let's verify that code. I'm going to call this color weight function. Okay, so there's no mistakes. Let me plug my Arduino in real quick. Hit Tools, Port, Arduino. There we go. Bruh. Oh, that's either plugged in the wrong place. Woo! That hit me. Okay. Go reset it. There it goes. See that color white? Alright, so that's cool and all, but that's just one color. What if we want to do all other colors? Well, that's when we can call this function again. Alright, so let's pick a new color. So we're gonna make it change a different color. Let's go orangey. Okay, 240, 130, 8, and 5. And 5, and I want to wait this one. I want to be a little bit slower. I want to see it really wipe that time. And how about before this one changes, let's add a delay in there because for 1 second, because why not? Let's just see what happens. Let's upload that one. Let's see what happens. Ooh, that's dirt nasty right there. Okay, let's see what else we can do with this therabod. Alright, so what if we also added something in here where color wipe canceled it out? Like after the LED turned on, it turned off. Ooh, let's try that. Alright. How would we do that? Let's say strip.set pixel color for I minus let's give it 2. Let's have it lagging 2 behind. For I minus 2, and let's set it to, can we just set it to low? Let's see what happens. Let's try it out. Oh, that worked. Oh, look at that. But that's weird. Why does the top keep staying? Well, if we think about it, what we're saying in this code here is we're going to turn everything off minus 2. So it's always going 2 back. But it doesn't ever reach the end because it can only go that far. Like the last number is 8, so it can only get to 6 as it turns off. So, what if we had the code artificially go, what if we said, hey, why don't you go 2 more spaces so we can trick this? Let's try that. So instead of it ending at the number of LEDs, which is 8, let's have it go to 10. So that way it goes 2 further. So let's say number of LEDs plus 2, which aka would be 10. In that case, so let's see what happens now. I'm gonna upload this. So we should see these two. Yep, there we go. Oh, look at that craziness. Let me get rid of this delay here. Let's go buck wild. Let's just get out of here. Get that out of here. Oh, look at it go. Let's throw in another one. Let's make this one really fast. Just having a little bit of fun here now. What color should we pick this time? Ooh. Oh geez, I didn't know I could do that. That's weird. Alright. Let's pick like a magenta or something. What's periwinkle? I've heard of periwinkle before. $80, $80, $100. Okay, periwinkle's boring. What about magenta? $255, $0, $255. Cool. So magenta is $255, $0, $255. And let's make magenta be really fast. So it's gonna delay for 10 milliseconds between each of these. Upload that one. Ooh, pew. See that quick flash of pink? And we could have this one run twice. To make this run twice, we could just easily copy and paste that one, have it go twice. Okay. We could also, instead of doing that, if you want to get a little sophisticated now, we could put this color wipe inside of a for loop. Let's say for the integer x, which we're going to set as equal to 0, as long as x is less than, how many times you want this to happen? Let's say we want the pink, the magenta, to go 10 times, and every single time we're going to add 1 to x. That way eventually it will die and end, which is exactly what we want. And we're going to do that. Put that last squiggle in there, upload that code. Oh, it's expecting, what does it want? Oh, right. These should be semicolons, not just commas. Alright, look at this, look at this. Okay, it didn't work. Wow, x is greater than 10. I can't read. Sorry, it should be less than 10. Oh yeah. Yeah, that's right. And if you wanted to, you could go on and set up, change this up a little bit, make your color wipe a little different. You can make 2 color wipes. You could have them that do slightly different things. But creating your own functions and calling your own functions is a super, super useful thing that if you ever do programming, you'll have to do. Before we go, let's hear from our sponsor, Rupert. Come here. Come here. Come here, buddy. This is Rupert. He's a dog. He doesn't like this. Bye.